Illustrative Math Geometry, Unit 1, Lesson 19 is called Evidence, Angles, and Proof. All right, so our goals today are I know what supplementary angles are and a linear pair or a linear triple. I know what complementary angles are, and I know what vertical angles are. All right, we're also going to, maybe you should add in there, I can prove vertical angles are congruent, but because we'll do that, but not necessarily a goal for the lesson, but something that we're going to do. All right, so mentally evaluate all the missing angle measures in each figure. So you should know that a straight line is 180 degrees. If you don't know that, I'm going to put a protractor up here, and I'm going to look here from 0 to 180, 0 all the way here. This is a straight line. It's exactly 180. So, if I look here, let's just say I have a straight line here. Or let's think of it like this. Here's an angle. Here's the other part of the angle. And if you think of this angle as, it moves and moves and moves, and then it stops right there. Okay, so when I look here, right there at the vertex, you see, it's 180 degrees right there from 0 to 180. Okay, 180 is a straight line. So clearly this angle here, this angle DAE is going to be 180 minus 50. This is going to be 180 minus 30. And then angle IEH is going to be 180 minus 150. And the same idea here, angle HEG is 180 minus 30. There you go. Same idea over here, 180 minus 65 would be, let's see here, 115. Obviously, angle FCD is all the way down here. That's 180. But I won't write it. Angle BAC, 180 minus 135 is 45. 180 minus 45 for angle DAB is 135. And angle DAE would be 180 minus 135 gives me 45. All right, before I move on to the next slide, I want you to take a quick look here, particularly at figure B and figure D. If you look here, these are both 150. And when I look here, these are both 30. So when I have two lines intersecting and going all the way through and forming an X, the angles across from each other have a special name that we'll talk about in a minute, but they're always congruent. Okay, same idea here. These 45s are congruent. These 135s are congruent. So these angles across from each other, not adjacent to each other, will always be congruent. Okay. So this is just a little warm up again here as well. Adding two angles. So the measure of angle FGH is this angle right here. You're going to add up the two values here. So 38 plus 35 gives me 73. Okay. And then come over here, the measure of angle FDE is what we want. So FDE, I'm going to put a little X in here. We know the measure of angle CDF and CDE. So CDE is this whole angle, and it's 101. And then CDF is this angle right here, that's 69. So really what you have is kind of the same as this, whereas over here we had 35 plus 38 equals 73. Well, here we have X plus 69 equals 101. So you end up having to subtract to find X. So you get X equals 32 degrees, okay? All right, so a linear pair. We kind of worked with this a little bit on the warm-up. A linear pair, a pair of adjacent angles. A linear pair is a pair of adjacent angles that, when combined, form a straight line. So adjacent means next to each other right here, okay? So meaning they add up to 180 degrees. So essentially two angles next to each other on a line that sum to 180. So here's here's a linear pair. Okay, so I can say here angle KIH and angle JIK are a linear pair. Okay, so you need to know that definition, a linear pair. Okay, now any two angles that add up to 180 are called supplementary angles. Okay, so let's say I break these up. Okay, let's say I got this angle here. Okay, and let's move it. I can move it. There we go. Say I move it over here, and then I take this angle over here, and I have that angle somewhere else. Let's say I move that. Right there. So these two angles, we know that they add up to 180. Let's say this was like 38 and this was 142. I'm going to measure them here in a minute, but they're supplementary, but they're not next to each other forming a line. So we don't call them a linear pair. Okay. So just be aware of that. Okay. So if you want to take this protractor here and measure these to make sure that they are indeed supplementary, we look here and we see, okay, this is 42 degrees. And then when I come over here, this one here is 138. It's a little bit less. You can kind of see it right here. Goes to the second mark. This one here is 138. So there you go. They add up to 180. All right. All right. So complementary angles are a pair of adjacent angles that, when combined, form a right angle. Shouldn't say line. Sorry. Meaning they add up to 90 degrees. So these are complementary. So angle X, V, Y, and angle W, V, X are complementary. Okay? So really, if you know they're complementary, you know that the sum of them equals 90. Okay? So you could, if this angle here was, I don't know, say 30 degrees, this angle here would be 60. Okay? But I don't know what the measure is. I'm just guessing. All right. So vertical angles. This is an important vocab word. Vertical angles are a pair of non-adjacent angles formed by the intersection of two straight lines. So here's my X. So vertical angles will be these ones and these ones, okay? Vertical angles are congruent always, okay? So make sure you understand that. Okay, now let's do a proof. I'm going to show you two different ways to prove this, okay? So the first one is just going to be with rigid motion, okay? So if I take this angle right here, all right, that angle. All right, let's name this too. Let's call this, X, Y, Z, W. We'll call this point here right in the middle C for center. Okay, so if I were to say, okay, let's do a rigid motion to move it down there. So let's say rotate angle XCY 180 degrees clockwise around point C. Okay, what's going to happen is this whole angle here is going to rotate. Now, pardon my thing, it won't let me change the center. It's going to rotate, and there you go. All right, it goes down there. And if you think about it, this X, 180 degrees, comes over here somewhere on the line. Okay, and this Y, I guess I went the wrong way. Clockwise would be this way. I guess I turned it the wrong way here. I guess it doesn't matter if you're going 180, which direction you go. So there it is. So this X is going to swing out down here somewhere on the line, and this Y is going to swing over here somewhere on this line. Not necessarily where the W is or where the Z is. It would be equidistant. So, you could think of it kind of like this here. Right there. So this X swings 180, pretty close to where the Z was, but there it is. Same thing with the Y here. That will swing 180. Oh, wait, I'm in the wrong spot. It's going to swing 180 right there. So, whoops. Move that thing. All right, so there's my Y prime, and there's my X prime. So there it is, okay? You can clearly see that they are congruent, okay, with rigid motion, because angles do not change with rigid motion, okay? I could do the same thing over here with this angle here. Trace it. Okay, and rotate angle YCZ 180 degrees. Pick a direction, clockwise or counterclockwise, around point C. Okay, so there is the first proof, rigid motions. Okay, the next way that you could do this is with a little bit of algebra. Let me clear this up a little bit. Oops, what did I do? All right, so if I just did this, let's call this A degrees, B degrees, C degrees, and D degrees. Okay, so we know that A plus B are a linear pair, so they equal 180. And then we know that B plus C is a linear pair, so those equal 180, right? So since they both equal 180, what we could do is we can say, oh, okay, well, since they're both equal to 180, you could just say, well, obviously A plus B has to equal B plus C, because they both equal the same thing. They both equal 180. And then if I do a little bit of algebra, okay, this is called the subtraction property of equality. Subtract B from both sides, we get A equals C, which are vertical angles, okay? And I can do the same thing with A plus D equals 180 and C plus D equals 180, and I would get D equals B. Oh, wait, no, I'd have to do D plus C and C plus B, and then I could get D equals B. All right, so there you go. There's your proof. Okay, so name a pair of vertical angles. So I'm just gonna pick a couple here. There's actually 4 pairs. I'll go here, angle 1 and angle 3. And then let's go down here. I'll pick 6 and 4. And remember, they are congruent. Vertical angles are congruent, okay? It's very, very obvious because you can just picture a rotation right there. All right, linear pair. There's actually 8 linear pairs here, so I'll just pick one from up here and pick one from down here. Angle G and angle 1, okay? Right here, they form a straight line linear pair. Down here, let's go, I don't know, 4 and 5. Okay, and supplementary. So all the linear pairs are also supplementary. You can't really be a linear pair and not be supplementary. You could be supplementary and not be a linear pair if your angles are not adjacent to each other, but they still add to 180. So, pick any other 2 here that are linear pairs. So, angle H and angle 6, or angle 6 and angle 5. Okay, any two that are a linear pair. Okay. All right, find the missing angle. So B and 85 are vertical, so you know all vertical angles are congruent. And then these are a linear pair, so it's going to be 85 plus C equals 180 minus 85 from both sides. And we get C equals 95 degrees, okay? Okay, there you go. And this one here we don't know, but it's obviously vertical to C, so this would be 95 as well. It doesn't ask us for it, but just for fun. All right, these are complementary. So A plus 59 equals 90. Now I know the 90 isn't written there as a number, but you got to know that this little box there in the angle means 90 degrees. Minus 59, minus 59, A equals 31. Okay. Now this one's a little bit harder. What I want you to do here is I want you to focus here first on this linear triple. All right, a linear triple is three angles that form a line just like a linear pair. So if you look here, this is 90, this is 68, and this is x. So basically 90 plus 68 plus x equals 180. So combine these two, I get 158 plus x equals 180 minus 158 from both sides. And we get x equals 32, no, 22, sorry. Okay, so this here is 22 degrees, okay? Now, why is this whole thing here? It's really 90 plus this angle. So if you look closely here, and I'll use some colors here to show you. If I just look at these blue lines here and try not to look at the rest of it, you can see that this little green mark is vertical to x. So this has got to be 22 degrees. So y all the way here is 22 plus 90 gives me 112 degrees for y. Okay? Use the properties that you know. Make sure you understand that these are not vertical, 68 and 22, not vertical. It has to be a full line. I don't have, if this extended, then I could say that this is 68, but I don't have that, so that wouldn't make any sense, okay? All right, find the value of A. Now we got a little algebra here. Same thing that we did before, it's just we got a little bit more work to do. So 50 plus 8A is going to be my equation, and now I minus 50 from both sides, and I get 8A equals 40. Divide by 8. So a little bit more algebra here, and we get A equals 5. Now, if it asks, this just says find the value of A, so we're done. But let's say I had points here. Let's say this was P, Q, R, and it said find the measure of angle P, Q, R. If it asked me to find the measure of it, I'd have to plug the 5 in, so it would be 8 times 5, which would give me 40 degrees, okay? But it doesn't ask us to do that. All right, these are a linear pair, so they are supplementary. So my equation will be 6A plus 1 plus 2A plus 3. You add them up and set them equal to 180. So I get 8A plus 4 equals 180. Minus 4 from both sides, I get 8A equals 176. Divide by 8, and I get A equals 22, I think. So 22, don't put degrees on that because that would be wrong, okay? A is just a value. When I plug it in here, then I put the degrees, okay? So just a little thing that I see people screwing up. If it said find the value of each angle, it would be 2 times 22 plus 3, which is 47 degrees. And then here, you could plug it in. You could do 6 times 22 plus 1, or you could just do 180 minus 47. Either way, you should get the right answer. So this is going to be 133 degrees. Okay? And then the last one here, these are vertical angles, so they are congruent. So you got to make your equation a little differently here. This time we have to set them equal because we know vertical angles are always congruent. So there's my equation. All right, so you're really just either adding them up and setting them equal to 180, or you're setting them equal to each other. You got to think, are they congruent or are they supplementary? So a little bit of algebra. So I get z minus 3 equals 7. Add 3. I get z equals 10. If I wanted to find the angle, it would be 8 times 10 minus 3, so 77 degrees go in here. I don't even need to plug it back in to this one because I know it's going to give me 77. So, all right. Thanks for watching this video. Hopefully you enjoyed it, and we'll see you next time.